The denominator goes to the numerator?
Yeah, the denominator has a negative exponent. And we already know negative exponents lead to a flip. So it's going to flip up to the top. So let me go ahead and rewrite that. Now, technically, what would happen is the whole thing would flip. So you would end up with x to the power of 5 over 1. But what do we know about fractions that are over 1? Do I need to write the 1?
No.
No, right? Anytime you have a fraction over 1, that is not something that you need to write. So we can just leave it as x to the power of 5. So that one, just x to the power of 5, that's it. Questions on number 1? Awesome. Okay. Now number 2 kind of goes the other way, right? Because we have a negative exponent again, but this time, where is it going to go?
Distribute?
So yes, so we can distribute it first. That's a great idea. And so that's going to give me 3 to the power of negative 2 and m to the power of negative 2. And I see in the chat Juan said they're both going to go down because that negative 2 is being applied to both of the 3 and the m. So both of them are going to belong down in the denominator. So we go 1 over 3 squared times n squared. And now there's just one last step. What can I do in the last? Yeah, let's simplify. So I can do 3 to the power of 2. 3 squared gives me 9. So I have 1 over 9m squared. Any questions on number 2?
I got the same thing. But I simplified 3 to the power of negative 2.
So did you skip any steps, or what did you do first?
I simplified 3 to the power of negative 2, and then I moved the m negative 2 to power negative 2 down.
So you had something like this. You had 1 over 9 times m to the negative 2, something kind of like that? Yeah. Okay, both ways work. So the cool thing about these types of problems is that as long as you're following the rules, there are more than one way to do it, and you should get the right answer as long as you're following the rules. So as long as you don't do something completely weird, you should be fine. So you'll notice that sometimes you might do things a little bit differently, and then you should still get the same answer at the end. So any other questions on this one, number 2? Awesome. Number 3. I've got a couple of m's, and since they have the same base, what can I do to their exponents?
Add.
Good, we can add these exponents. Now I'm going to rewrite this problem just so you can see exactly why I can do this. Remember that what is holding the 2 and the m together? Multiplication, right? So I'm just going to rewrite this. I'm going to rewrite this m to the power of 4 times 2 times m to the power of negative 3. And we know that with multiplication, you can kind of move things around. It's called the commutative property. I can move things around in a different order. So for example, I could write the 2 out here, and then the m to the power of 4, and then m to the power of 3. And the reason I did that is just to show that those 2 m's, you can sort of combine them together by adding their exponents, because with multiplication, we can move things all around, and therefore that 2, we don't really need to worry about it. Does the 2 have an exponent of its own?
No.
No, it does not. So we leave that 2 right where it is. And then 4 minus 3.
1.
Right. And sorry, let me back that up. Why did I say 4 minus 3? That's because I'm doing 4 plus negative 3. Remember that when you add a negative, when you're adding a negative number, you're taking it away. You're actually subtracting. So 4 minus 3 is 1. So I have 2m to the power of 1, but do I need to write that 1?
Not really.
Nope. We just leave it as 2m. Okay, so any questions on numbers 1, 2, or 3? Anything so far? The other 2, which other 2?
One, it's 2 times m and m.
2 times wait, say that again.
2 times m, the 4 and 3. Wouldn't it be 4? Wait, yeah. Wouldn't it be 4m?
No, because there's only one single number 2, right? There's only one 2 there. Do you see that? There's no other 2. If there was another 2 out there, then yes. But I think maybe what you're thinking of is if you had like 2 times, but that would still actually be
Yeah.
2. So yeah, no, the 2, because of the commutative property, because of it's just multiplication, we're just going straight across. So it's 2 times m to the power of 4 times m to the power of negative 3. There's no other 2's.
Because I was thinking the m to the power of 4 times m to the power of 3 would also give you 2.
Oh, right. Okay, good point. So you are putting those 2 m's together, but you're not, remember what exponents do. Exponents tell you to do repeated multiplication. So it's kind of like, let's say you had m to the power of 4 and m to the power of positive 3. That would be the same as m times m times m times m. So that's m to the power of 4. And then you keep going. Oops, m times m times m. That's m to the power of 3. How many m's are there in total?
7.
7, right? So this would be m to the power of 7. So we're doing the same thing. It's just that the 3 was negative, so that's why we're taking away m's. But that the m's didn't randomly get a number in front of them. There's no coefficients. There's nothing in front. We're just kind of putting together all of the exponents into one. That's how that works. So that's how we end up with just 2m, and that's it. Any other questions on number 3? Okay. All right, number 4. Number 4 gets a little more complicated, but what do we have to do first?
Distribute.
Distribute. Okay, everything gets a negative 1. So I get 2 to the power of negative 1 times x. Now we start multiplying the exponents. So 4 times negative 1 is negative 4. And then what's negative 3 times negative 1? A negative times a negative
A positive.
is a positive. So negative 3 times negative 1 is positive 3. Okay, now I see some negative exponents. So what do the values that have a negative exponent, what happens to them?
They go down.
They go down. So which ones are the only ones going down into the denominator?
2 and x.
2 and x. Everything, the y is going to stay exactly where it is because it doesn't have a negative exponent, so it doesn't have to go anywhere. So
on top.
right, yeah, it stays on top. Remember that whole numbers, technically whole numbers are in the numerator. So like the number 8 is in the numerator because you can rewrite that as 8 over 1. So when I say that the y is staying exactly where it is, I'm just saying that it's staying in the numerator where it already is. Okay, and then down at the bottom, I get 2 to the power of 1 times x to the power of 4. Do I need to write that 1 on the 2?
No.
Nope. So I'm going to just write this as, let me actually move this up a little bit. Okay. So I get y to the power of 3 over 2x to the power of 4. So those are my 4 problems about exponents. Do I have any final questions on exponent rules? Because today we are finally moving on from exponents. Kind of, not really. Any final questions? Okay, great. So now we've got these radicals. Let's start with number 5, the square root of 125. The square root of 125. Is that going to be a whole number?
Square root? Oh, I thought we were simplifying. Oh no, I messed up.
That's okay. So you can always check, if you happen to have your calculator, you can always double check and just see what happens. If I try to take the square root of 125, I get this long, long number. I get 11.180339887498895. So that's not going to work out. You can't get a nice whole number by taking the square root of 125. But what is this telling me to do? This is telling me to simplify. So what I'm going to be doing is we're going to rewrite this. But that doesn't mean I'm going to give you the final answer. What that means is I'm going to rewrite it. And what I want to do is I want to take out as many perfect squares as I can out of the radical. Remember what I talked about yesterday? It's kind of like inside the radical is like very claustrophobic. It's like a little cage. You want to take things out as much as you can. So in order to do that, we need to split the 125 into 2 factors. Can anyone give me a pair of factors that include
25 and 5?
Perfect. 25 and 5. Now, why is that a good choice?
Because
Those are the greater ones.
And what kind of special number do we have there?
25.
What do we call that number?
A root base? No. I was going to say root beer for some reason.
Nope. The number 25 is a type of perfect square. Because remember, perfect squares are all the numbers that you can take the square root of. So 25, 36, 49, 64, 81, all of those numbers. Perfect squares. And since it's a perfect square, you can take the square root of it. So this is the square root of 25 times the square root of 5. And what is the square root of 25?
5. Wait.
5.
No.
Yeah.
It's my bad. I'm sorry.
So we get 5 times the square root of 5. 5 root 5. Any questions on simplifying square roots? We're just rewriting them. We're not giving away the actual answer, but we're rewriting it in a way that takes out as much as possible from underneath the radical. It's like you always want to have, when you simplify, you always want to have the smallest possible number here. You always want to have the smallest possible number that you can. That's the goal. So with 80, the square root of 80, what can I split it up into? The number
16 times 5.
16 times 5. Nice. Beautiful. And that's a great pair of numbers because the number 16 is what type of number?
Perfect square.
It's a perfect square. So 16 and 5. And then the square root of 16 is?
4 times 5.
So 4 root 5. You always want to say root so that I know that there's a square root there. So 4 root 5. 4 times the square root of 5. Cool. So that covers pretty much everything that you guys have been working on in the last week or so. So how do we feel? Any final questions on these couple of topics?
How do we know that we're simplifying?
Read the question. It'll always, if it says the word simplify, this is what you're doing. If it says the word evaluate, then that means they want a number as your final answer. So
okay.
That's the difference, yeah. Give me 1 second. I have to plug my computer in. I have to get my charger.
The solution for 6 would be 2, right?
What do you mean the solution?
I mean, like, the number.
Well, what's the square root of 80? Go to your calculator. Plug it in. What is the square root of 80?
A big number.
A big number, right? Square root of 80, for me, it tells me it's 8.944271909999159. So that's why we don't end up writing that, because this is not, and we'll talk about this tomorrow, but this is not, this is what we call an irrational number, but we'll talk about that tomorrow. Now, how could I figure out approximately what the square root of 80 would be? Without a calculator, how do I approximate that answer?
Round up.
We're going to round, yeah, because what is the nearest perfect square to the number 80?
9.
So the perfect square is 80 is, yeah, 81.
Oh, 81.
81, right? Square root of 81 is 9. So I know that the square root of 80 is going to be something very close to 9, but just a little bit less, which is what we had, right? We had 8.94427.
Oh, I just said that. I'm like 8.9. I didn't even look at the calculator or nothing.
So see, you were really close just by estimating it to the nearest perfect square. Cool. All right. So that's our bell ringer. Now we get to actually get started. So before you start writing anything down, let me just explain what's happening. So in the past week or so, we've talked a lot about exponents. We've had exponents that are positive numbers. We know what happens when there's exponents that are 0. And we know what happens when you have exponents that are negative. So we've talked about positives, negatives, and the number 0. But we've kind of ignored a type of number that's very important. We've ignored fractions. So what we're going to be doing today is seeing what exactly happens when the exponent is a fraction. So we have what's called a rational power, which we also can call a fractional exponent. So anytime that your exponent is a fraction, it's going to follow one of these two rules. So we can kind of split this up into rule number 1 and rule number 2. And what I want you guys to write in your notebooks at this time is what's in that box. So go ahead and write this down. And just have it in the, write in your notebook on today's page so that you can refer back to it as often as you need. I'll give you guys about 3 minutes to copy. All right, so finish copying, and then I'm going to go ahead and get started with these examples. But let's just examine what is happening here. So take a look at rule number 1. When you look at rule number 1, notice that the exponent is a fraction, but a very specific type of fraction. It's a type of fraction where the numerator is just 1. So it could be 1/2, 1/3, 1/4, 1/5, anything like that. Well, when you have an exponent that is a fraction, what actually happens is that you can rewrite it as a radical, and it can go back and forth. They're equal to each other. And whatever number is in the denominator, whatever that number n is, well, that's just going to be the type of radical that you have. And we know a couple. We know that there's square root. When you have a square root, what is technically the number on the outside?
2.
A 2, right? Now we usually don't write it. So let me go back to these examples. We don't write it, but on example number 5 and 6, you can think of it like an invisible 2 that is just sitting there on the ledge, on the balcony. So we know that there's square roots, there's cube roots, that's when you have the number 3, but there's really, you can go as far as you want. You can have the number 4, number 5, and number 6, any number can sit out there on the balcony. So that's what happens when you have a fraction over 1. So let's take a look at example A. I'll call this A. Example A, we have an exponent that is 1/3. So I can rewrite this as a radical. The number 8 sits on the inside. And since I have 1/3, the number 3 sits out on the balcony of my radical. Well, we know that the number 3, what type of root is that? That's not a square root, that's what?
Cubic root.
A cube root, yeah. And remember yesterday we wrote down all of the ones that are important to memorize of the cube roots. And the number 8 actually is a perfect cube. Does anybody remember, or can anyone tell me right now, what is the cube root of 8?
2.
2, good job. Remember that the cube root is the opposite of going to the third power. So, for example, 2 to the power of 3 is 2 times 2 times 2, which is 8. So going the opposite way, the cube root of 8 gave me 2. Any questions on example A? Okay, well, that's my answer. For example A, I end up with 2. Now, looking at example B, I have a fraction again, but this time it has a numerator as well as a denominator. Well, let's look at rule number 2. When you have a fraction that has a number in the numerator as well as the denominator is the one that ends up out on the balcony, and then whatever's in the numerator stays as a whole number exponent. So let me kind of sometimes for me, it was really hard to remember which number goes outside and which number stays inside. So let's think about it this way. Just imagine, just forget math for a moment. And let's say you have 2 friends. Well, hopefully you have more than 2 friends, but just imagine you have 2 really good friends. And one of them ends up betraying you. He or she just does something really terrible. And your other friend is like the best friend in the world. Like they're a really good friend. So think about it. The one who's your best friend is on top. This is your BFF. Is on top. The one that ruined your whole life, that's your enemy. They're on the bottom, right? Like your best friend is on top, your enemy is on the bottom. Who do you want in your house with you? Your BFF or your enemy?
The BFF.
Yeah, you want your BFF to be inside the house with you. So there they are. BFF gets to come inside the house, and your enemy goes out on the curb. They got to stay outside. So if you remember it that way, the person on top, that's your friend, you want them in the house. The person on the bottom, you don't like them, they're going to stay outside. So if you ever forget which of those numbers ends up outside, which of those ends up inside, that's a kind of useful way to remember it. So with our example B, I have 25 to the power of 3 over 2. So I know my 25 stays, is at home, it's going in. Who's going to be inside the house with the number 25?
3.
Good. The 3 is on the inside. And the 2 is on the outside. Questions on that so far? So right now we're just kind of rewriting it. But I can actually write this 2 different ways according to rule number 2. I can write it like this, or I can write it as follows. I can kind of have it in these parentheses. So my 25 is right where it is. My 2 is still out on the ledge. And my 3 is out here. Now the reason you can write it both ways is because sometimes it makes more sense to take the square root first and then apply the power. So what does that mean? That means that, take a look, can you do the square root of 25? Is that something we know how to do? Yeah, it is. So I know that the square root of 25, what is that?
5. Wait, no.
5.
Yes,
Yeah,
5.
it's 5. And then I still have to take it to the third power. Well, I know how to do that as well. What's 5 to the power of 3?
125.
125. So doing it, grouping it in this way, grouping it so that the 3 ends up outside, can be more helpful because those are 2 operations that I know how to do pretty easily. Now, on the other hand, if I did it the other way, let me show you why that's a little harder. Because if I group it the way that I have it grouped right here, where I have the parentheses inside, that would mean that I have to do 25 to the third power first. So that's a little harder, right? Because now I don't know what that is right off the top of my head. I'm going to need a calculator, or I'm going to have to write it down. 25 times 25 times 25, and I'm going to have to figure out what that is. Luckily, I do have a calculator with me. So I get 15,625. So now I have to do this. Now I have to do the square root of 15,625. Now I don't know about you, but I did not memorize that one. Did you? That's not one of the ones that I'm supposed to memorize.
No.
So you would definitely need a calculator for if you did it that way. Now I do have a calculator, so I know that it ends up being 125. You still get the same answer, but you can do it either way. So you can either do the square root first and then the exponent, which is what works better, or you could do the exponent first and then the square root. So each type of problem you work on might work better one way or another. So it's important to kind of think about logically which one is going to be easier to do. You end up with the same answer, but one way is significantly easier than the other. Okay. Now, I know we're just starting on this, but are there any questions so far? Okay. I'm just replying. Cool. So let me erase this one so that I can highlight the better way to do it. And there we have it. Okay. Oh, what just happened?
Oh no, it deleted everything now.
We'll see. Oh no, it did. It's okay. We didn't do too much on this page.
True.
So this one was the cube root of 8, which is 2. And then that was the square root of 25 to the third power, which is 5 to the power of 3, which is 125. Okay, cool. Well, just like we know we can do these with actual numbers, actual values, we can also do them with exponents, with variables. The only difference is that you're not going to get a final answer, you're just going to rewrite it depending on like how it's written at the moment. So this one is written as an exponent, we can rewrite it as a radical. So in this case, who gets to live inside the house with my y?
3.
Good. 3 is on the inside, and the 8 is on the outside, and that's all we're going to do. We can just leave it because we're not going to get an answer. It's just that all we're really trying to do is rewrite it the other way. And then with my final example, I have a radical, so I'm going to rewrite it as an exponent. So I'm kind of going backwards now. So who is on the numerator? Who's on top?
2. Wait,
2.
No.
Yeah. 2 is on top. And 7 is on the bottom. So it's just a matter of understanding how to go back and forth, how to write it one way with the radical, how to write it one way with the exponent, and understanding, how to take which number goes on top, which goes on the bottom, which one goes inside, which one goes outside. So going back and forth. And what we're going to do, this is the only new thing we're learning today. From here on out, it's all practice problems. So we're just going to practice it and practice it and practice it until we feel a lot more comfortable. But at this point, any questions? Okay. So let's get right to it. I'm going to leave the rules up on the right side today throughout the whole class, but it is something that you should have memorized by tomorrow, basically, because we'll do it over and over again. You won't have trouble memorizing it. So here's problem example number 1. 4 students have rewritten the expression with a rational exponent, m to the power of 5/3, in radical form, as shown. Who has rewritten this expression correctly? I'm going to put up a poll. Give me a second. So take a look at the 4 students and then determine which one wrote it correctly. Okay, 20 more seconds. Go ahead and put your responses in the poll. All right, 5, 4, 3, 2, and 1. All right, let's take a look. Answer choice C is the winning answer. And now let's actually take a look at it. So I have m to the power of 5/3. So it's a matter of following those rules. We're not getting a final answer. I'm not going to say, oh, the answer's 5. No, we're just rewriting it. So if you take a look at our rules, we know that what happens to the 5? Does it end up on the inside or the outside?
The inside.
Inside. So there's the 5, and then the 3 has to sit out on the balcony as follows. So the only person who had that correctly was Alicia. Answer choice C is correct. So good job if you chose answer choice C. Now be careful with answer choice A. So Dexter had it backwards. Dexter put the wrong number in the wrong place. And then Martha and Trevon seem to have confused something, right? Martha and Trevon, they put it as a coefficient. So remember that it starts off as an exponent. Those numbers are exponents. So they're going to stay exponents. This is going to be an exponent, not a coefficient. So that number always, it's inside, it's with the m on the inside, but it's going to be an exponent. So Martha and Trevon didn't quite understand how to do this correctly. Any questions on this one? Good. All right. Like I said, we just have a lot of practice problems today, so let's keep it going. We're going to rewrite each radical expression as an exponential expression. So we're going to just rewrite it using exponents. So it's kind of backwards. This time I'm starting with the radicals, and I'm going to convert them into exponents. So take a moment, take about 30 seconds to start thinking about what those answers will be. And then if anybody's feeling brave, you can annotate it onto the screen. But just wait, give yourself about 30 more seconds to have the answers on your sheet of paper in your notebook. Okay. So before we start writing down the answers, the 2 on the top, so the square root of k and then the square root of k to the power of 3, what's the invisible number that's actually sitting out on the ledge?
One.
Not 1. Think about it. It's the square root.
Two.
So 2. There's a 2 out there. We just don't usually write it when it's a square root. We don't really write it. Now, that's going to be a little bit helpful. Now, take a look at the 2 questions that are on the left side. So on the top, we have the square root of k, and then underneath we have the 8th root of k. Is there an invisible number inside the radical?
No.
So k is by itself, but when a number is all alone, what's the exponent?
Is it 1?
Yeah, it's 1. Okay, so both of those, technically, they have a little invisible 1, and that's going to help us to rewrite these values. I'm going to do the first one as an example, and then all the rest of them, I'm going to ask for volunteers to annotate it. So starting with the first one, my exponent, I know there's going to be a 1 and a 2. Which one's on top, the 1 or the 2?
1.
Good, so it's 1 over 2, 1/2. K to the power of 1/2. Now, would anyone like to annotate? If you want to, just go for it. Go ahead and annotate on the screen the answers for the remaining problems. Good. It's hard to write it, isn't it? Good, so I see k to the power of 3 over 2. I see k to the power of 1 over 8, very good. And what about that last one? K to the power of 2 over 8, very nice, good job. Now with this last one, k to the power of 2 over 8, can I simplify that at all?
Yes.
Yeah, what can I simplify that to?
4.
1 over
4.
1 over 4. So I can simplify it. So good. Any questions on how to go kind of backwards, how to convert from a radical to an exponent? Take a look at them, see if you have any questions. And also, I know it's hard to write. Totally understand it's hard to annotate on the screen. So I don't blame you guys at all. But when you're writing it on your notebook paper, make sure that you make your exponent nice and small so it doesn't look like you're multiplying. Like if you write it too big, it might look like you're multiplying those values. Just make sure that your exponent ends up nice and small and you make your base number nice and big so that you know that you can clearly see that it's an exponent. Okay, so let's keep it going. Let's do a couple more. Let me erase. Okay. So now we're going to match the expressions in the first column, so on the left, to their equivalent expressions in the right column. Now this is something I do want you guys to write into your notebooks. I know it's kind of a lot, but go ahead and start writing it down. Take about a minute to see if you can come up with the right answers for this one. Okay, now before we go through it, we're not going to annotate it quite yet. What's going on here? We have a little bit of extra work to do, don't we? In example A, before I can figure out my final answer, what should I do first? Oops.
Simplify. Wait,
Yeah.
no. Yeah.
Yeah, I've got an exponent on the outside. I need to multiply it with the exponent that's on the inside. So I got to do 3 times 1/2. What's 3 times 1/2?
3/2.
3/2. Yeah, 3/2. 3 times 1/2 is 3/2. And then I'm going to keep doing that all the way down. So for B, I got to multiply again. What do I get here? 2 times 1/2.
1 or 2/2.
Good. 2/2 or just 1. I'm going to write it as 2/2. Okay. How about C? 2 times 2/3.
4/3.
4/3. Good. 4/3. And then finally, okay, I got a fraction times a fraction. 2/3 times 9/8.
16/27.
Remember that you don't cross multiply. We're going across, straight across. So 9 times 2.
18.
18.
So we got 18 over
24.
24. Good. Can I simplify that? (18 over 24). What does that simplify?
1 and no, it's not 1.5. 2 over something. I don't know. I forgot.
I can reduce this fraction. So 18 over 24. What is the numerator and the denominator divisible by?
You can divide it by 6.
By 6, yeah. So 18 divided by 6 is 3. Oops.
Oh.
And 24 divided by 6 gets me 4. Yeah, 3/4. Good job, Karina. Okay, now I've got all my answer choices kind of simplified a little bit. Let's go ahead and take a look at the matching. So if you would like to, you can annotate. Go ahead and annotate and match. Draw a line going, or you can, okay, or write the answer, Juan. That works too. Go ahead and do that. Good. So the one on top, that's going to be the last one left, which is answer choice C. Now, quick thing I wanted to go over is there's one answer choice that we can simplify even further. Can anyone tell me which one it is? I kind of left it as a fraction, but I could have gone even further.
2/2.
Yeah, 2/2. Like Juan mentioned, 2/2 is just 1. Just 1. So we know that 13 to the power of 1 is just 13 on its own. Well, let's take a look at how it's written over here. Here we have the square root of 13 to the power of 2. And we kind of know, we talked about this yesterday, the square root is the opposite of going to the power of 2. Same as multiplying is the opposite of dividing, adding is the opposite of subtracting, right? So taking the square root is the opposite of going to the power of 2. So if you have the square root of something that's going to the power of 2, these cancel each other out. The square root cancels with the exponent. So you could have also realized that this is just equal to 13 because they cancel each other out. And that only works if they have the same value. So if I had the cube root of 8 to the power of 3, the same thing would happen. The cube root cancels out with the exponent. So you would just end up with 8. Okay, does that make sense? Does anyone have any questions on that idea? Cool, cool. All right. So moving right along. This one's a good one. I like this question. This one's very similar to a question that it will be on your test, the next test you guys take. It's not for a little while, but I know for a fact that there's a very similar question to this. So select all of the expressions that are equivalent to 64 to the power of 2/3. I want you guys to try this. Start trying it out on your own. I just want to see how much you guys can already do, because I know you guys can do quite a lot on your own. And I'm going to launch a poll for this one as well. And it's select all, so more than one answer might be correct. Take about a minute and a half, maybe 2 minutes. All right, take about 10 more seconds to make your selections. If you feel comfortable with it. If you're still a little lost, that's okay. Just pick ones that you know for sure. And then if you're not so sure about other answer choices, then that's okay. Because there are a couple that everybody should feel pretty good about. Okay. All right, let's take a look. So, okay, pretty much 6 out of 7 people chose E. That's good. E is definitely going to be one of our answer choices. And then as far as everything else, some people chose them, some people did not. So let's take a look. Let's take a quick look. So I have 64 to the power of 2/3. So let's start breaking this down. So I know based on my rules, based on the rules that I have right here, I know that I can write this 2 different ways. I can either just have, like we've normally been doing, I can just have which number goes inside?
2.
2 goes
2.
inside, good. 3 goes outside. Just this way, which is answer choice E, which almost everybody chose. That's good. But based on my little rule, I can also write it with parentheses in this format. So I can also say that we've got the cube root of 64 to the power of 2. So that kind of like forces you to think about the cube root first. So do the cube root first and then worry about the exponent. Now, the reason this is helpful, and by the way, this is answer choice F as well. The reason this is helpful is because now we can actually evaluate, we can get a final answer by following those 2 steps. Would it be easier to do the cube root and then the exponent, or should I do the exponent first and then the cube root? In other words, should I go with option A right here? Or would it be easier to do option B?
A.
Okay, let's see what happens if we try A. So if I'm trying to get an answer, in option A, I have to do the exponent first, because technically it's like there's little parentheses inside. So I got to do 64 squared. Do I know off the top of my head what 64 to the power of 2 is?
No.
No. And let's say you don't have a calculator for this part of the test. I would have to do it by hand. 64 times 64. Oops. Okay, so 16, 24, 25, 24, 6 times 6 is 36, 37, 38, 6, 9, 11, 4. Okay, 4,196. So now I have to take the cube root of 4,196. Now, see where I'm going with this? Does this seem like a easy thing to be doing? If you chose that route, would this be easy numbers to work with?
No.
No. I don't want to be doing this on a test. I don't want to have to do the cube root of 4,196 without a calculator. No way. I am not doing that. So it's easier to go with option B. If I do it instead of doing the exponent first, let's do the cube root first. Because guess what? We know what the cube root of 64 is. We wrote it down yesterday. This is one of the ones that you should have memorized. What is the cube root of 64?
8.
8. Do we agree?
Yes.
So 8 times 8 times 8 gives me 64?
No, 8 times 8.
Oh, no.
Oh, see, that's the square root of 64. So careful. What's the cube root of 64?
4.
4. Yeah, 4 times 4 times 4. 4 times 4 is 16. 16 times 4 is 64. So the cube root of 64 is 4. But I still have that exponent. So this is now 4 squared, which also brings me to answer choice C. And then I know what 4 squared is. What is 4 squared?
B.
16. So answer choice B was also one of the answers. So see how when you follow the rules, when you take an exponent that's a fraction and you turn it into a radical, remember, you always have two options. You can do the square root first and then the radical, or do the exponent first and then the radical, or you can go the opposite way, do the radical first and then the exponent. And like we did just now, doing it this way was going to be way easier than doing it the other way, because we know what the cube root is. That's something that, like I said, you should have memorized already. If you didn't, then keep working on memorizing it. We got to know the cube root of 8, cube root of 27, cube root of 64, and the cube root of 125. Those are the 4 important ones to have memorized. So if you have those memorized, if you already know off the top of your head the cube root of 64 equals 4, then this problem becomes a way, way easier to do pretty quickly, much faster. How we feeling? Questions on this? If there's any part of this that you don't understand, if you don't know where I came up with those values, let me know now. Okay. All right. Okay, I have a couple of people. let's be more specific. So if there's something you don't understand, I'm gonna number this. This was step 1, step 2, step 3, and step 4. Let me know which step you're having trouble with. Okay, step 2. So I'm gonna erase a couple of things. So first things first, this is what we started with. You can write this 2 different ways. I'm just looking at the rule right here. I'm just literally looking at the rule and following it. I can write it this way or that way. They're both equal. They mean the same exact thing. It's just a matter of what I'm grouping together. In the top option, I'm grouping together 64 squared. In the bottom option, I'm grouping together the cube root of 64. One of those things is easier to do than the other. Think to yourself, what is easier? Is it easier to do 64 squared, or is it easier to take the cube root of 64?
The cube root.
Cube root, because like I said, that's something you should have memorized. If you don't have it memorized yet, you should have it memorized now. Cube root of 64 is 4. It's a very easy thing to just know off the top of your head. 64 squared, I don't know that off the top of my head. I'm going to need a calculator for that. But on a test, you might not have a calculator with you. So it's much easier to take the cube root because that's something that we've already memorized. So when I go to the next step, I'm going to go with this option because it's grouping together the cube root. So now I'm just going to, I know that the cube root of 64 equals 4. So I have my 4. But I still have this exponent right here that's not going away. So I got to bring it down. So then now I have 4 to the power of 2. And I can rewrite that because I know what 4 squared equals. 4 squared equals 16. So the steps to getting a final answer, it was step 1, rewrite the radical. Step 2, take the cube root of 64. And then step 3, 4 to the power of 2 equals 16. So it's very, very like, we're just going to keep following those 3 steps. Any remaining questions on this one? Awesome. Okay. Here we go. 4 students were asked to solve the equation below. 5 to the power of 1/3 times something, I'll put a question mark, equals 5. Their answers were as follows. Which student or students answered the problem correctly? So basically what this is asking for is what goes in the blank. Which of those answers that those 4 students had belongs in the blank where the question mark is. So what we got to think about is what's going to help us to basically get rid of our exponents. Now what I'm going to do is I want to rewrite a couple of these because the thing is, we know that you can write these numbers, you can write them as an exponent or a radical. But you got to make sure that things match. So in this problem, I already have an exponent. So which students should I rewrite so that everything matches? Because I already have an exponent, so who do I have to rewrite?
Sharon and Alice? Wait, no. Sharon.
Just Sharon.
Well, Sharon also has an exponent. That's 5 to the power of 2/3. So Sharon matches. So does Alice. They both have exponents. Alberto and Rocio have radicals. They have the cube root. So I need to rewrite those in order to work with the values because things have to match. If you already have an exponent, you want this to be an exponent as well. It should have an exponent in order to work with them together. So I'm going to rewrite Alberto and Rocio. Hope I'm saying his name right. So how would I rewrite the cube root of 25 as an exponent?
25 by the over 1/3.
Good. 1/3. Remember, there's an invisible 1 on the inside, so that 1 goes on top. So it's 25 to the power of 1/3. How about the cube root of 125?
125 by 1 over.
To the power of 1/3. Good. Now here's another question. Are any of those, let's just actually, let me write these down here. Look at Alberto and look at Rocio one more time. Will any of those be a perfect cube? So is 25 a perfect cube or is 125 a perfect cube?
25 will be a perfect square.
25 is a perfect square, but not a perfect cube, right? So that one's not. What about Rocio?
He is a perfect cube.
Perfect cube. Good. What is the cube root of 125?
5.
Good. 5. So that's simplified. That's the most simplified you can have it. Alberto, on the other hand, let's think about it a different way. I know that 25 is 5 to the power of 2. Do we agree? We agree? 5 squared equals
Yes.
25. Okay.
Yes.
So I'm going to rewrite this a different way. I'm going to write, this is the cube root of 5 squared. All I did was I rewrote the number 25 as 5 to the power of 2. The reason I'm doing this is because remember what the exponent rules are. If you're multiplying two numbers, let's say you have 3 squared and 3 to the power of 4. What do you do to those exponents?
Add.
We add them, right? So you get 3 to the power of 6. But does that work if I had something like this? Can I add those exponents?
I don't understand.
Can I add them? Can I also get 6?
Yes.
Juan's saying no. Why not?
Oh, because they don't have the same base.
They don't match, yeah. They don't have the same base. So now I'm looking at this problem. And I know that if I want them to cancel out, if I want to be able to multiply, because this is a multiplication problem, they need to have the same base. Must have the same base. So I want the base to also be a 5. So that's why I'm rewriting this, because if I had the number 25 or the number 125, the bases wouldn't match each other. So by writing it this way, I have the base being 5. So Rocio is 5 to the power of 1, technically. And then Alberto, how do I rewrite this as an exponent? This would be 5 to the power of
2/3.
2/3, yeah, 2/3. All right, so now I've got all these matching bases. Now let's actually see what happens. I'm gonna go with Alberto first. I'm just gonna put his number in there. 5 to the power of 1/3 times 5 to the power of 2/3. What do I do to those exponents?
Add.
Good, yeah, we add them. And what do we get? 1/3 plus 2/3,
3/3.
3/3, which simplifies to
1.
just 1. So 5 to the power of 1 or just 5. So Alberto gets what we want it to be. We wanted it to be 5, and that one worked out. So Alberto gets a check mark. Let's take a look at Rocio now. I'm going to put in his number. He had 5 to the power of 1. But again, I'm adding the exponents. So what do I end up with in the end?
2/3.
Not 2/3. I'm doing 1/3 plus 1. So how do I?
1 and 1/3.
4/2. No, yeah.
4/2.
2.
This is 3/3.
Oh, we need to make it the same denominator to add them, right?
Mm-hmm.
Okay.
So I see Juan put that down. 4/3 is what we end up with, which is 1 and 1/3. But I'm going to rewrite it as a improper fraction. So that does not work out. We don't get 5. Rocio does not have the right value. Sharon, well, Sharon has the same number as who? Who else?
Top.
Yeah, same number as Alberto. And we already know that 1/3 plus 2/3 gives me 1. So Sharon's also good to go. And then Alice, 5 to the power of 3, just 3. 1/3 plus 3, what's that?
4. The same as Sharon? No, wait, Rocio.
Let's see. 1/3 plus 3. How do I rewrite 3?
9/3.
3/1.
Well, it's 3/1, but they need to have matching denominators. So like Lauren said, that's going to be 9/3. 1 plus 9 is 10, so 10/3. So again, that does not work out. The only ones who do are Sharon and Alberto. So Juan put it in there for us. That's our answer. So this one, see how like we started with something a little bit kind of simple, like we're following that pattern, and it's going to get more and more challenging. It's kind of like a puzzle. All of these questions are a lot like a puzzle that you have to piece together until you figure it out. So we're going to keep going with it. There's still quite a few. We're only halfway through this PowerPoint. We're going to keep practicing. Any questions on this problem?
How did you get 9 for the fraction again?
Good question. So we were doing 1/3 plus 3, right? And just like you said, 3 is the same as 3/1. But we need to have matching denominators. So how do I turn the 1 in the denominator into a 3? What do I multiply it by?
By itself? Wait, no.
I'm trying to get it to become a 3. It's a 1 right now. So what do I multiply it by?
3.
To turn a 3, right? But then I need to do 3 times 3, 3/3. So this is 1/3 plus 9/3, 9/3. Because 9 divided by 3 gives you what?
9.
3.
Gives you 3. 9 divided by 3 is 3. So I'm just rewriting the number 3 as 9/3 so that I have matching denominators, and then I can add 10/3. Adding fractions, multiplying fractions, all of those little things that you guys practiced and learned in the 6th grade and a little bit in the 7th grade, that's just something that in algebra you should just know how to do. And obviously not everybody does, and we still need to practice it as much as possible because it doesn't go away. All right. All right. Couple more. Ooh, now we got really, really interesting. Let's just take a look at this. So which expression is equivalent to 1080 over 625 to the power of 1/2? So there's kind of a lot going on here. There's a lot of steps we're going to need to take. So let's go ahead and just start it off and see how far we can go. So I have 1080. And remember, we're always just following those exponent rules. So starting with, what do I do with this exponent that's outside of the parentheses?
Distribute.
Distribute it. Good. And I know that I can distribute it to the top and the bottom. So this is 1080 to the power of 1/2 over 625 to the power of 1/2. Well, now I have an exponent that is a fraction, so I can follow my rule for rational powers, fractional exponents. How can I rewrite this as a radical?
Subtract?
Well, no. Okay, so we're not going to subtract, because in order to subtract, it has to have matching bases. Remember that anytime you want to add the exponents or subtract the exponents or anything like that, you have to have matching bases, which we do not have. So can't subtract, but we can convert. We can turn the exponent into a radical. So how do I rewrite this expression as a radical?
Oh, okay. So we do for the bottom.
540.
540.
For the bottom, we do 625. I mean, for the outside. I don't know. Can I annotate, because I don't know how to explain it?
Okay, go ahead and annotate, and then I'll rewrite it so it's on my screen. Right, so we're noticing how we have an exponent on who's a fraction. Right, that exponent is a fraction. So I know that the number that's on top will end up inside, and the number that's in the denominator will end up outside. So just like we've got here written down, I know it's hard to annotate, I understand. So we have the square root of 1080 and the square root of 625. That's exactly right. Good. Okay, so that's what we got so far. Now from here, let's take a look at the answer choices. What do you guys notice about the answer choices?
They simplified it.
Yeah, they simplified these square roots. Sorry, I'm just rewriting it. 1080, 625. They're rewriting it, they're simplifying it. So let's start with the numerator. The square root of 1080. Matter of fact, go into your calculators. I'm going to let you cheat so that we understand. Go ahead and open up a calculator and try it. What is the square root of 1080?
25.
You sure?
Oh, I thought you said 625.
Oh no, the numerator. The square root of 1080.
A decimal.
Okay, we
Yeah.
get this long decimal, right? So the numerator, we're going to simplify that one. And the denominator, now try that one, square root of 625. I think Ajira said it. We get 25. So the denominator, you can you can just get an answer, 25. But the numerator is going to have to be simplified. So we're going to think about, huh?
We can eliminate answer choice A and D.
Yeah, definitely. Yeah, we can eliminate A, we can eliminate D. That's good. Now, remember, in order to simplify, we need to think of factors of 1080. Now, it's a little bit tricky. That's not an easy number to think of. But let's see what we can come up with. 10,080. Can anyone just, I don't know, just try and see. Try it out on your calculator, trial and error. See if there's any.
540 times 2.
Good. 540 times 2. And keep breaking that down. See if there's anything further.
Three and 360.
360 times 3. Nice.
216 times 5.
216 times 5. All right.
4 times 70.
4 times what?
270.
270.
6 times 180.
What times 180?
6 times 180.
Good.
8 times
135 times 8.
135 times 8.
9 times 120.
And then 9 times what?
120.
120. Good.
108 and 10.
108 times 10. We're getting closer and closer. Keep going. And move these up.
These are a lot of multiples.
Yeah, it's got a ton of multiples of factors.
12 times 9.
12 times
90.
90.
Fifteen times 72.
You got it. 15 times 72. You guys are super, super close to the one I'm looking for. Because I know the one I'm looking for, but we'll see if we get it.
18 times 16. I mean,
16 times what?
20 and 50.
no, 8 times 16.
8 times 16. 8 times what?
60. 60.
60.
20 and 54.
20 and 54. Okay. And what I'm looking for, remember, we're looking for perfect squares. So I'm going to circle the ones we've got so far. I have 9 as a perfect square and 4. But we're looking for the largest one. So those are still pretty small.
Wait, the largest one? I thought you said the smallest one before.
Nope, largest, definitely largest.
Oh, okay.
24 times 45.
24 times what?
45.
Good. Should be the next one, I think.
$27 times 40.
Ooh, keep it going.
$30 times 36.
Ooh, 30 times 36. Bingo. Take a look. There's a perfect square, 36. We got there eventually. So of all of the factors, it's got a ton of factors, but the largest one that's a perfect square is 36. So I can rewrite it. 1080, rewrite it as the square root of 36 times 30. So that's the square root of 36 times the square root of 30 over 25. And I can take the square root of 36. What is the square root of 36?
6.
6. So we got 6 root 30 over 25. Took a long time, but we got there. We got there in the end. I'm going to show you guys a quick little shortcut that you can take when you're working on something like this. Remember what I said, we're looking for the highest, the largest possible perfect square. That is a factor of 1080. Well, I know my perfect squares. I know that it's 4, 9, 16, 25, 36, 49, and on and on. So what I can do is I can do 1080 divided by, let's say, 9. Okay, so 9 works. Then I try it again, 1080 divided by 16. 16 doesn't work. 1080 divided by 25. Nope. 1080 divided by 36. Ah, then you figure it out. So instead of finding every single factor, you can check to see if there's a factor that's a perfect square. So it's a little bit of a shortcut. But in the end, this was good because we kind of saw how long this process can take, and you guys did it the hard way, and now you know how to do it kind of the easier way. So B is our answer. Any questions? This was a long one, so any quick questions on this one before we're almost done? Awesome, awesome. Okay, so here's the plan. I had just a few left, 1, 2, 3, 4, 5 more problems. Some of them are easier than others. What I think I'm gonna do is I'm gonna just put these as bell ringers for the rest of the week. And yeah, because I do wanna move on to the next, to the next chapter. So we're gonna see these later on this week, even though we didn't get to them today. But there is one assignment. It's all multiple choice, Khan Academy. So kind of easier, but it reviews everything that you guys learned today. It's already up. It's due Friday at midnight. It shouldn't be too hard. I tried to keep it still a little bit simple. So try your best. Remember, with Khan, you can do a Khan Academy assignment as many times as you want. And it doesn't matter as long as the only thing I ever see is your top score. So if you started it and you did poorly, but then you do better, I only see the top score, the highest score you got. So it's worth it. Keep doing it more than one time if you want to complete it with 100%. All right. So any quick questions before I let you guys go?
No.
No? All right, you guys. Good job today. Well, I know that what we're learning is tough. It can be confusing, but you guys are pushing through and I appreciate it. So have a nice rest of your days. I will see you guys tomorrow.
Chicken nuggets.